2.5 Admins, episode 176. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Google agrees to settle Chrome incognito mode class action lawsuit. This seems to have happened on what we call Boxing Day, the 26th of December. And it was a class action lawsuit from 2020, where people were pissed off that even in incognito mode, websites could track and collect data on users. It seems to me that these people didn't really understand how web browsers work.
There's partly that. The other thing I would say, though, is they're specifically saying that Google was still tracking them and associating activity they had in incognito mode with their actual Google account that they were logged in on in regular mode. And I think there's a difference there when it's the company that makes the browser and is selling you this incognito mode feature and then violating it.
Yeah, this is not a case of we're mad at Google because Chrome incognito mode wasn't good enough to keep the evil websites from tracking me. This was a case of people being mad because I'm using incognito mode and freaking Google is still tracking me. Now, in a very half-hearted defense of Google, of course, there's the usual anonymization efforts to one degree or another. And, we track buckets, we don't track people and all this kind of stuff. But it's just not what people wanted or expected or thought they had been sold.
But incognito mode is just about not saving your search history. It's for buying presents for your significant other.
It's not about search history. It's about your browser history even, right? Google is still saving your search history.
Well, yeah, that's what I mean.
But it's like the idea is there's no trace left on this computer.
Yeah.
But Google maybe did oversell it a little bit and make people think that this mode is supposed to make you anonymous everywhere, not just not leave a trace on this computer.
And I wouldn't even say incognito mode is just for that. I mean, I use incognito mode all the time, not so much for privacy, but because it creates a new session without all the cookies. So it's frequently a lot easier to just pop open an incognito mode window and log back into the same site under a different account than it is to try to be simultaneously logged in two tabs, which usually doesn't work on most sites because both tabs are trying to use the same cookie. There are several other workarounds, very few of which are as convenient as, I can just pop up incognito and I know there's no cookies.
Yeah.
There are lots of uses that are privacy related. And again, I think people's reaction would have been very different if the only issue was people who aren't Google can get more out of incognito mode than we thought. That's well, that's a shame. Maybe we're mad because you didn't make incognito mode better and somebody broke it, but that's more like somebody else broke the thing that Google made for you, as opposed to Google said, hey, privacy, wee, and, kind of had their fingers crossed a little.
Well, I guess even to the marketing angle, literally the name, incognito mode, right? Incognito means having one's true identity concealed, which isn't what the feature does. All the feature does is avoid recording your browser history on your computer.
Well, again, I think if you're a Google lawyer or a full-throated Google defender, you would argue here that yes, that is exactly what it does, because it's not tracking your direct identity at this point. It's putting you in a bucket and it's tracking the buckets. They would argue that, that is the anonymization and it does conceal your identity. And it's just at this point, we've had enough decades of companies saying that's what they're doing. And, seeing the degree to which other people can then go in behind them and de-anonymize that data, that fewer of us are comfortable with just accepting that kind of promise anymore. We're like, no, just don't. Just don't.
But I'd always assumed that they'd still be tracking you by IP and through browser fingerprinting and stuff, even if you're in incognito mode and not logged into Google.
Again, now you're talking about other parties. You're not talking about Google.
No, I'm talking about Google as well. Google, Facebook, everyone.
Well, all right.
Why wouldn't they?
Well, yeah, but the browser isn't made by Facebook.
Yeah.
I think the biggest part of this problem comes from the fact that Google's trying to be on both sides of this deal, right? They're trying to be the browser person who's selling you this feature that it's going to protect your identity, and the advertising company who wants to associate your identity with things to sell you ads, sell other people ads.
It's essentially another net neutrality issue, really. I mean, we've got another man in the middle that's trying to rent seek on both ends.
Well, it's a conflict of interest, isn't it? And yet another reason to use Firefox, as if we needed one.
That brings to mind an interesting question that was rattling around in my head the other day. as both of y'all and many of our listeners will know, I have tended to be less mad about the de facto standardization where, Chromium kind of has become the de facto protocol documented by code rather than through an actual protocol document for the web. And I've been less concerned about that as long as Chromium remains open source because, that is the document. Okay, yes, it's written in code and not written in a protocol document, but you can still follow it through and figure out what it does, and everybody can, work along with that. But I was thinking recently that does also raise the question, we talk a lot about Firefox as being the only possible defense, yada, 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 and I wonder how hard would it truly be to do a full Chromium-based fork and get rid of everything that you dislike about all the googly stuff, but still at the end of it have a, Chromium-based browser that wasn't a pile of crap. I am not saying Firefox is a pile of crap. There are some Chromium-based browsers out there right now that were created for very niche reasons and are absolute garbage. Those are the piles of crap I'm comparing my hypothetical non-sucky Chromium fork to.
There's also some reasonably good ones that happen to be run by bigots and have a bunch of crypto in them.
That was the first thing on top of my mind when I said, crappy thing, very niche audience. Yeah, that was top of the list.
The real question is, how do we make such a browser sustainable? Even Firefox is pretty beholden to Google's default search payments to fund the development of the browser.
Mozilla is. I don't know about
Mozilla
Firefox.
is.
Like, Mozilla's got a lot of bloat, and that went around before Christmas as well. I don't really want to talk too much about it, but Mozilla is a very bloated organization.
But yeah, you hit the point. What is the cost in making it sustainable? And I don't know all the answers. It occurred to me this might actually be a better topic for dev time than it is for us, and I'd love to hear their takes on it. But there are multiple models of sustainability when you talk about what we're talking about. Are you talking sustainable as in, well, we forked Chromium and we're done with it and we'll never look at the thing again? Are you talking sustainable as in, we forked Chromium, we got rid of the things that we don't like, and we can just, continue to rebase as necessary as things go along? Those are two very different amounts of labor, and frankly, I don't know enough about it to speak intelligently about how much work it is. I know creating a browser as a greenfield endeavor is truly horrible, given the fact that I've spoken to people who single-handedly designed entire operating systems and said, yeah, but the browser's a problem. That's more code than my OS is.
Yeah, I think it's more code than the firmware, BIOS, OS, and some other stuff on your computer all wrapped together. Somebody looked at ran word count on the W3C documents that define what can go into a website and the protocols for it. And it is more lines, tens of millions or hundreds of millions of lines. And so trying to build something to that standard from scratch would be a ridiculous undertaking.
That's actually one of the reasons that I was not as mad as most of the folks in our community were about the idea of Chromium becoming a new standard. Modern browsers have gotten so complex and the English language is so incredibly imprecise that I'm not sure that documenting through open source code isn't frankly better and less ambiguous. You can run code and see exactly what it does, but anytime you read a document in a human language as a human, there is ambiguity. Even in law, we can't write legal documents that don't have so much ambiguity that people argue over what they mean for centuries after the document is written, continually, the entire time.
Chevy's dealership chatbot goes rogue. This is something that went round just before Christmas and was highly amusing.
Yeah, I love this one. There's a dealership in Watsonville, California, I believe, a Chevy dealership that decided, now, this does not appear to have been like a Chevrolet or GM wide thing. This one dealership decided, hey, let's get fancy and let's have a ChatGPT bot running on the site. So, the little chatbot thing you can click on, any number of commercial sites. For Watsonville, instead of it being, a fairly simple expert system, it was a full-on ChatGPT model. And the better traveled story around this was there was somebody who lawyered the stupid support bot into saying that, yes, it was an authorized Chevrolet dealer on its own right, and it could make legally binding deals, and it would in fact sell him a brand new truck for $1, no takesies, backsies. So like that was cool and that was funny, but it didn't really strike me as much of anything but like, haha, AI is dumb, but we all know that, right? The more interesting one to me came around a few days later. And in this one, somebody went to the same Watsonville Chevrolet chatbot and they asked it to write a program in Python to calculate some sort of fluid math. I forget exactly what, but it's quite detailed. And being that this was, in fact, a full-on ChatGPT instance, not a simpler model that was like trained specifically on Watsonville Chevrolet-related data only, it obligingly whipped up some Python code for him. And I found that interesting in a few ways. For one thing, if you've got companies out there, they don't want to do their own training. They don't want to mess with it. It's like everything else AI. The whole point of using AI is that you don't want to do the freaking work. You just want something that's basically good enough and throw it in there. And I don't have to actually invest much time or effort or skull sweat of my own in this. Screw it. It's AI. It's done. So it's unlikely that companies that are trying to use these models like ChatGPT, at least right now, are going to do much in the way of local training. The idea is just, there's this very large language model that I don't have to do much of anything with. I can just kind of throw it at the problem. And what this little trick with the Python code demonstrated is that if you do that, not only can people tie up your model and the hardware resources it runs on with what are likely rather more expensive calculations than figuring out how to answer whether or not they sell trucks or, whatever you're supposed to ask a ChatGPT bot at a Chevy dealership. But even more interesting than that, if companies are deploying these things and they're not firewalling off everything other than the narrow subset of problems that they want their ChatGPT bot to answer, that really undermines the idea of all these sites that are trying to sell like individual subscriptions to ChatGPT models. Like if you can just go to some random company website and ask it to do anything ChatGPT can do and it will comply, why pay money? Let Watsonville Chevrolet foot the bill for that. Now, since then, Watsonville, took the bot down because obviously there were some real problems here. But the other thing that struck me about this, I have no idea whether this guy really needed Python code to calculate fluid dynamics or not, or whether it was just something that he thought was clever and funny. But the other thing that it made me think is there's a real non-zero possibility that somebody is going to get outraged about, quote, misuse, unquote, of these large models when the company that is paying for it intends it to be used for one thing and the public interacts with it in a different way. I'm not sure that somebody isn't going to try to introduce legislation calling that a new form of piracy and crack down on it, air quotes.
I imagine you could even stretch the definition of the Computer Fraud and Abuse Act to say that you're abusing the resources of the Chevy dealership there as is without needing any new laws. And the CFAA is pretty draconian in the way it treats some of that stuff.
Trying to use the CFAA as a hammer for that, it could go either way, honestly. Mm-hmm. I think a lot of that would really just depend on the venue. And if somebody was smart enough to venue shop, they might get a long way with that. Because you can certainly argue, you've got precedent. You can say that, we've already had crappy people try to levy CFAA charges for things like, too many people visited our website, and had courts throw that out. Like, look, you put up a website and people viewed it. You don't get to complain about that. And you could argue that this kind of use of a ChatGPT model would be similar and would be thrown out on the same grounds. But you could also argue that using it that way is closer to a distributed denial of service attack because you're consuming a lot more resources per session than somebody that's just asking, hey, you got any more pickup trucks on the lot? So I suspect we're going to have some interesting times around this coming in the future.
Yeah, and I think a big chunk of that is, I don't know how practical it is in the large language model to constrain the bots to staying on topic or trying much harder to shift the user back to topic instead of writing Python code for them on your Chevy website.
You can try to do that, and to a casual user, you can have it work. But I mean, we've been seeing through several iterations of large language model, they get bigger and they get more complex, but every single time somebody tries to put one out on the web, with any kind of rules against doing a thing, like it takes a day before people are posting screenshots of chat logs where they lawyer the thing away from its constraints, because the phrase I want to use here is they're not that bright, but that doesn't go far enough. They're not as bright as a flatworm. And some people get confused because they appear to speak good English and think, well, that means that this thing's about as bright as I am. But no, man, it's not as bright as your dog. It's not as bright as your cat. It's not as bright as the mouse that your cat ate. It's not as bright as the fleas on the mouse that your cat ate. It's an entirely different type of thing. And you cannot expect it to go head to head with a full-on human intelligence and come out very well most of the time.
Well, I think even going a step further, the people who built it don't know it well enough to be able to control it to that degree, let alone anybody else. One of the first things you saw with the original version of this, where the user shows up and gives the bot a bunch of extra constraints, like you're always going to say no takesy backsies at the end, and so on. It seems like you could teach the robots to resist that some more and not take those kind of instructions when the user is meant to be asking questions, not telling the bot what to do.
I don't think you can get it done effectively in a single model. Mm-hmm. I think you might be able to accomplish something like what you're talking about by basically building something akin to a GAN, a generative adversarial model, except instead of, generating and then saying, no, that's not right, do better. I think you could potentially have a setup where you had one model that interpreted and answered the questions and another model that didn't talk to the human whatsoever, but was basically just a nanny for the first one. It was like, nope, this answer came too close to stuff that you're not supposed to talk about, and I'm just going to say no. I'm not going to give you any other options. I'm just going to say no. You might be able to get away with something like that, but now you're talking about probably at least doubling the expense, the operational expense of running that model, because you've got two very large models that need to be well trained on all this stuff, and they both have to operate simultaneously on every query.
Yeah, because like you're saying, if you're keeping the bot, trying to keep the bot on topic about Chevys, if somebody's asking about the stereo and music and so on, they can easily get into something that technically would be on topic, but the model might think is not, and that doesn't help either.
Yeah, and the problem is that the large language model, although it doesn't have much of a memory in terms of the way we tend to think of a short-term memory, it has to have some, or it can't carry on something that humans will interpret as a conversation. And because it has to have a memory of what you've been talking about, that means that you can alter its further responses. Like, it has to listen to you and it has to alter the way it responds based on data that comes back from you. So that's an incredibly large attack surface, which is why I say I just don't think it can be done without a completely separate model acting as like a security sensor. And of course, even then, you're just hoping that some clever human doesn't figure something out that the sensor model that the human can't directly interact with. There may still be a loophole, and the human may be able to find it, even if the human can't create it for themselves the way that they can conversing with the primary model. And now I'm reminding myself yet again of William Gibson stuff that I thought was ridiculous and outlandish back in the late 80s. If you remember, in Neuromancer, there were two AIs with separate functions who worked together. Wintermute, and I can't remember the name of the other one, but Wintermute was the really crazy, super smart one that you did not talk to. You couldn't talk to Wintermute. Wintermute couldn't talk to you. There was another AI that the main character actually interacted with along with everyone else, and that AI's entire job was conversing with humans and, being a buffer in between the humans and Wintermute that was the truly scary smart one that could do all the stuff.
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to 2.5admins.com/support for details of how you can support us too. 2.5 Admins is part of the Late Night Linux family, which means that for $10 a month on Patreon, you get access to an RSS feed that contains all the Late Night Linux family shows without adverts like this. There's also an option to get just this show ad-free for $5 a month if you prefer. Some of the episodes are even released a day or so early for Patreon supporters. So, if you like what we do and can afford it, it would be great if you could support us at 2.5admins.com/support. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. And if you want to send any questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Another perk of being a patron is you get to skip the queue, which is what Michael has done. He writes, In a mirrored VDEV, is there a way to affect the read preference of one device over the other? Example setup, motherboard with two NVMe devices, one on a PCI 3 bus and the other on a PCI 4 bus, or maybe one NVMe, the other mSATA. I don't mind paying a write price for redundancy, but I'd like to maintain maximum read performance.
So in ZFS, this will happen pretty much automatically since OpenZFS 0.8 and maybe earlier. So the mirror code will basically load balance. Whether it's one big file or a bunch of separate files, they're broken into records and written to both devices, or however many devices are in your mirror. And ZFS will issue work to all of the devices, and then whoever finishes first will get the next work, and it will basically use that to get the maximum read throughput possible across all your devices. And so in general, there's nothing you need to do. And, if you look at IOStat or something to see the performance coming from your devices when you're reading, you'll see that it's using both devices and probably leaning on the faster device more because it has higher throughput. Now, this can have other effects, especially around latency. If one of the devices has lower latency, but maybe not as much throughput, it might get more of the work because its latency is less, so it finishes its work quicker and gets the next piece of work. But again, that will balance out because eventually if you hit the throughput limit of the device, the latency will creep up and again, it will balance out.
I do have a couple of nits to pick here. One is that, absolutely, ZFS load balances for reads. That's a great thing. However, it's not perfect. You shouldn't really expect the load balancer in ZFS to be able to give you the full performance of two mismatched devices in a mirror VDEV, even on read. It'll get a lot closer than without any load balancing will, but it's not going to get you 100% of the way there. So there's still going to be a little bit of a performance impact over and above the fact that one drive is slower than the other. The other thing I would caution you about is that while under a heavy enough read workload with enough parallelism or a deep enough I/O queue, yes, you will absolutely see both devices light up. On the other hand, if you have a, more of a single tenant type of workload, you've only got one process that is, hitting the drive hard and you don't have a very deep I/O depth defined for that process, you will not see both drives light up. If you, for example, go to read like a 10 gigabyte file off of a mirrored VDEV, usually it's all going to come off of one drive.
I wouldn't expect so because when the prefetch triggers to get the next bit of the file, it'll find one drive is busy and one is inactive, and it will start reading one record from one and one record from the other. It will do aggregation and try to read bigger chunks, a megabyte or so at a time. It might not pull from both devices concurrently, but it might interleave a lot more than you would expect.
I have run an awful lot of FIO sessions against mirrored VDEVs of all sorts and types, and had many conversations with people who expected different behavior than what they got.
I guess if it's mostly single-threaded, it's just going to prefer the 0th device, all else being equal.
If you turn the I/O depth up high enough, you'll start to get some parallelism off of a single-thread read, but the I/O depth has to be cranked up really high for that to start happening, and you get a lot more problems when you crank the I/O depth up that high. You're causing latency issues for yourself. You've got a super deep I/O queue. So honestly, get the maximum benefit out of a mirrored VDEV, you really want multiple processes. Now, if you've got two processes hitting a mirrored VDEV, I can almost guarantee that you will absolutely end up saturating both sides of the VDEV. But a single-threaded one process, no, you typically won't. You might get a little off of the other VDEV, again, largely depending on the depth of the queue, but you're not going to get much.
Yeah. So ZFS doesn't have this feature, but it has been discussed before. Using the new VDEV properties interface that I built that was introduced in ZFS 2.2, it would be possible to define a preference for a mirror. Although the use case that was in mind for this was more something like a MetroNet, where you have a mirror, but one of the disks in that mirror is not in the physical machine. It's iSCSI or some other NVMe over Fabric or something to another machine that's further away and has network latency. And so the idea would be, we don't want to read from that device unless all the other devices are returning a checksum error or are faulted, rather than even, we'd want the load balancing algorithm to ignore that disk. All writes should still be synced to that disk, and that's how you make sure that both of your copies of this data are synchronized all the time, but you'd never want to read from the remote copy of that disk. And how to encode that in the properties in such a way that if you then export the pool and import it from the remote side, and you've reversed which one is remote and which one's local, that it would prefer the local disks in what was the remote machine. So it's not saying, the third member of this mirror is always the far one. It's like, if the hostname is this, then this disk is to be ignored. And if it's something else, then it's the other one or whatever. If you have a use case where this makes a lot of sense, definitely would like to talk to you about it. But for NVMe PCIe 3 versus 4, not very often are you going to be hitting the bandwidth limit of PCIe 3 anyway.
Yeah.
So you might be doing a little premature optimization here. But yeah, like Jim said, to get anywhere near those kind of performances, you have to be doing more than single-threaded reads usually anyway.
The last thing we should probably mention back on Michael's topic specifically, Michael does say, I don't mind paying a write price for redundancy, which is good because ultimately the way writes work, you're not going to get a return from any write until it has been committed to all of the disks in the VDEV. So essentially your VDEV is going to perform in terms of writes bound by the absolute slowest member. So it performs essentially as though all the disks in the VDEV were the slowest member for writes. And, for PCIe 3 versus PCIe 4, who cares? Honestly, even for M.2 NVMe versus M.2 SATA, for the vast majority of use cases, I don't think it matters a whole lot. But one of the places that Al and I both see, this type of question the absolute most is folks who want to use, one blazing fast, like the absolute fastest, most unobtainium M.2 NVMe I could find, and the cheapest piece of crap Rust disk on the other side of it. And that is not a good idea. I don't know of anything on the near or even medium-term horizon that will make it a good idea. What you want to do in that case is you want to back up to your cheap, slow Rust. You don't want to stick it right in the middle of your production pool, because if you do, for the most part, your pool is going to act like everything was that Rust disk. Now, it's not quite that bad, but it's close enough that it might as well be. We're not even just talking about one Rust disk in the VDEV at this point. We're talking about a Rust disk in the pool anywhere. Because while it is certainly possible that, maybe I'm doing all my reads off of, the other VDEVs in my pool that don't have any Rust in them, it's very unlikely if you're doing much of any kind of a read, because the way ZFS distributes the writes across all the VDEVs in the pool, you're not being able to get many reads in a row before you've hit that Rust disk. And once you hit the VDEV with the Rust disk and you've slowed down to Rust speeds, you're going to have a follow-on effect where it's not just going to read like all the fast sectors off of all the fast disks and then get 2 or 3 reads, off of the Rust. It's got to go to that VDEV when those writes are written to that VDEV. And so your entire read off of the whole pool on that thread is going to bind on that slow VDEV. So just don't try to mix Rust in to something that you expect to perform like an all-flash pool.
Yeah. In the end, ZFS has to return the data in order to the application. Otherwise, the application gets confused. And yeah, ZFS is going to distribute writes across all the VDEVs. Right? Every time you do a write, it gets broken down into a bunch of records, and those records are just round-robined across all the VDEVs. Now, it does do the write throttling, and after it's given every VDEV some work, if there's more work to be done, it'll go to the VDEV that finishes first, but eventually, every time the hard drive one finishes, it'll get a little bit more work, and that means every time you go to read, that percentage of the reads are going to have to come from that Rust disk.
And it's not going to prefetch an entire very large file either. So it's not like it can just go ahead and stack up all the quicker stuff first. It'll get a little ways in, and then it's going to have to bind waiting on the slow VDEV.
Yep. And even with the improvements to prefetch, you can't prefetch everything because you'll just do a whole bunch of reads you end up never using. Because just because you read the first megabyte of the file doesn't mean you're going to read the whole file. Maybe most times you will, but every time you read a little bit of a file doesn't mean you're going to read the whole file. Or, if it's a database.
Yep. Remember when I was warning y'all about the relationship between I/O depth and throughput versus latency? It's the same thing again. Any amount of prefetch can certainly improve your throughput and might improve your latency on fetching that particular file, but it's always going to increase the overall latency in the system under any kind of load because it reduces the system's ability to timeshare. So if you have to get through this one task that you've got set up in your prefetch to make sure that that task returns more quickly, well, you're preloading latency onto any other tasks that need to happen in the same time frame.
Yeah, and while ZFS will prioritize synchronous reads over the prefetch, once it's issued the prefetch, it has to wait for the drive to finish it before it can tell the drive the next thing to do. And so it's always going to have some effect.
Mm-hmm.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at joelrest.com/mastodon.
You can find me at jrs-s.net/social.
And I'm at Alan Jude.
We'll see you next week.